Okay, so first of all, disclaimer, I'm very new to vCluster. I don't think that I can explain it quite okay, but and I'm also like an engineer, so I'm not like a good presenter. So my presentation skills are going to be a little bit dry, and compared with Dan, it's going to be a mess. But let's get on with it. So the title of the presentation is The Challenge of Building Cloud Native Platforms on top of Kubernetes. Quite a mouthful, but this is kind of like what I've been thinking, doing, and just working with different projects for the last 2.5 years, I would say. So who I am, my name is Mauricio Salatino. I am working for VMware right now. I joined like a year ago just to work on a project that's called Knative. I don't know if you know Knative. Somebody knows Knative? Yeah, okay, cool. It's just a project that works on top of Kubernetes, and I think that I will be showing a little bit of that later on. I think that I consider myself like a good issue finder on open source projects. I just go play around with open source projects, find so many issues that I need to go and fix. So I'm just contributing to a bunch of things because I just find it like fun. And I'm also writing because of this, playing with all these projects, and because I've been working with Kubernetes for like 5-6 years already, which is kind of crazy. I'm trying to put all the things that I've been learning in this book that is still in the process of being written. There is a link there for 35% discount if you're interested. It's very like in the drafts right now. You can access the draft and provide comments and all that stuff. So I will leave the slide for a little bit longer so you can see that there is a code. Buy it. I will just leave it a little bit longer. Just buy there. Like you can just go and buy it. I'm just kidding. It's it's just for the love of art. So the agenda for today, it's pretty simple. We will be talking a little bit about building platforms on top of Kubernetes. This is something that I've seen people like large companies doing more and more and more. It was a very big topic in Valencia. Like there's a lot of people talking about this. It's definitely like what the industry is thinking about nowadays. Then a little bit about like the challenges. Again, coming more from like a developer perspective, not more from the infra or like VMs. I don't know much about VMs, but just much more from like developers using Kubernetes to deploy applications and to build stuff on top of it. And I have a demo which is pretty simple, but I wanted to show you. So simple, depending on how you look at it. So the need of for building platforms, I think that Dan did a great introduction about multi-tenancy and the problem that you will face if you have a Kubernetes clusters and you want to share it across different teams. There are like two sides of it, kind of like on the spectrum, right? Like you have companies that say, I would just create this huge Kubernetes cluster and I would share it across teams or maybe like even across customers. That's kind of like one option. Usually for people starting with Kubernetes, that's the only option that they have because they are learning and they know about namespaces, so they go with that and until that breaks in some way, right? Remember that if you're creating Kubernetes clusters, if you're on-prem, good luck with that. That's an entire thing. But if you are like on cloud providers, when you create a cluster, that's going to be tied to a region, right? So sooner or later, if you have customers all over the world, you will need to have Kubernetes clusters in different regions, and then you have multiple Kubernetes clusters, right? So one Kubernetes cluster mostly kind of like start breaking there when you have multiple teams installing different tools, writing CRDs, extending Kubernetes, making sure that people do not interfere with the work that they are doing. That's kind of where it becomes really, really messy. And that's the basic fact, that is that different teams will have different requirements and different needs to install different tools and work in different ways with that single cluster. By having a single cluster, you have a single like API server that everybody will be using, and that's, again, it becomes really, really messy. And one thing that also like the Kubernetes community is looking into a lot is about like that, like pushing developers or everyone building applications to understand how Kubernetes works and Kubernetes limitations and how do you need to containerize and run your applications for building these systems. Because that's fine, like learning Kubernetes is fine, but pushing everyone in the organization to understand how it works, it's just too much, right? Like developers should be focused on building new features, adding value, or fixing bugs. So in the context of this presentation, what is a platform and why do we need one, right? And this is basically my definition, which is a little bit not super correct, but I would say that for now, like a platform is just a collection of services that are exposed via APIs, focused on automating and providing a self-service approach to consume complex infrastructure and tools. So the idea here is that we are creating a bunch of APIs that will allow our application development teams to say, I need an environment. So I want to create one, but I don't need to know actually if that's a Kubernetes cluster, if it's a namespace, if we are using vcluster, how it's configured or anything of that. They want an environment, they should be able to get one. That's kind of like the main idea, and the reason why we build these platforms is just to reduce the cognitive load on people that it's consuming this infrastructure. When I talk about platforms, you can think about like Google Cloud. It's called Google Cloud Platform, so it is a platform. AWS and Azure is also a platform, and other cloud providers are providing similar things. But the idea here is that we are one level up into the organization, right? Like Google Cloud and Amazon, they will give you generic services, like for example, creating Kubernetes clusters or creating buckets or creating databases. But when we are talking about platform here, we are talking about like the specific needs that an organization will have, right? So we are building a layer on top that it's basically very specific and custom for the organization that it's going to use it. So if your developers need certain tools to do their development, the platform should be able to configure all these tools and provide that environment for them without them knowing how all these configurations are done. And the main idea here is also like that the platform is going to expose an API. So there is a lot of automation in here. You should be able to interact with an API and get the things that you need, right? Like, and if you are a developer interacting with an API, that's what you know how to do. So you just do that. And by providing the right platform, the right APIs, the right automation, what we are trying to basically improve is like our delivery practices, right? Like just delivering more software in front of our customers. With all of that, and this kind of like been organically growing in the last 2 years, is the idea of having platform teams inside of our organizations, right? Like, and the platform team is a team that is in charge of basically understanding what the application development team needs, creating an API to provide that and provide all that automation, and to interact with the infrastructure team to deal with all the infrastructure related topics, including Kubernetes. Right. There is a book that it's really good that describes all the interactions between the different teams and how you should kind of like change your mindset about how do you organize people around these concepts. That's called Team Topologies, highly recommended. This is quoted in every platform talk that you will see nowadays. It's kind of like the default place to go and learn more about it. But that book, it doesn't talk anything about Kubernetes or anything. This is just about building generic platforms. And I think that we are at the point in the Kubernetes community when we are now basically translating all these concepts into Kubernetes specific things and figuring out how to not only deal with Kubernetes, but we'll deal with the entire CNCF landscape, which is a wild space of technology. It's like kind of crazy. So there are challenges, and as you can see, the last one is just dealing with all these like ever-changing software components and tools that we are getting into these communities, because it kind of like it's a full-time job to keep up with all these things. So to start with like challenges, if you are starting with Kubernetes, if your organization is new into Kubernetes, having a multi-cluster setup, multi-clusters, and managing all these things is complicated. Even if you are creating clusters in cloud providers, just dealing with that becomes really just the full-time job. You need to have people that are experts on managing these infrastructures. And cloud providers will give you some tools, but depending on what you are doing, you might need to build some layers on top of that. If you add multi-cloud to that, then it becomes just crazy, right? Like if you want to run stuff on Azure and Google and manage all that across in a single control plane, it's too much. Again, it's just only like the more mature organizations can do that kind of things. And then related with the amount of tools that we have, installing and maintaining platform-wide tools, it is complicated. And curating which tools are we going to use to do certain things, it just takes time, and it takes a lot of time for people just to research and understand what tools are the best to do the thing that they are trying to do. So the proposal here, and I've been looking recently more and more around tools that are just focused on building platforms, like in helping people to create these APIs and abstractions that will allow them to deliver some of these in an automated way by reusing some of the Kubernetes core concepts. So the expectations for a platform that I will be showing in a bit is that we will have like application development teams that they need an environment to do their work. That environment for my company will be completely different from your company, right? Like the tools, the way that it's created, where it's created, in which cloud provider, using kind of like what infrastructure and all that stuff. So the idea is these teams should be able to say, platform, give me an environment. The platform should give that team an environment so they can do their work. And as Dan mentioned, like isolation is kind of important, right? Like that environment will be isolated from all the other environments and they will not interfere between each other, so they can do whatever they need to do there without worrying about that. And then the idea is that you will have a platform team that will be creating that platform and deciding how all these tools are going to be configured and defining this kind of like API to say, okay, if you need an environment, this is the kind of request that you need to send me, and I will just send you back the credentials for accessing this environment. So in order to build a platform with these expectations, application development teams requesting environments, platform team exposing an API, we are going to be using these tools. Crossplay. How many of you know about Crossplay? Have you used it a little bit? Yeah? Not that much? You know Crossplay? Yes? Perfect. Yeah. Crossplay is again another very popular project there in the CNCF. We will be taking a quick look at it, at what it does and why it's very beneficial for building these kind of things and why it's usually associated with building platforms. vCluster, you already mentioned that, which is pretty nice. I'm brand new into the community, but I'm already loving it because that table that Dan showed, it's basically the selling point there, right? Like you have namespaces or clusters. Now you have another thing in the middle, which is great, which is usually what you need for doing certain things. And then I will be talking a little bit about Knative serving and Knative functions, which is the project that I'm working on like 24/7. So with Crossplay, what do you do? With Crossplay, you can provision cloud resources, very abstract. You can provision cloud resources using the Kubernetes resource model, right? So in the same way that you create a new deployment into a Kubernetes cluster, you can send a YAML file that says, create me a new cluster. And Crossplay will take that YAML file and it will create a a GKE cluster inside Google Cloud, right? And that's pretty advanced, but it's pretty nice because you can extend that to say, okay, create a cluster, but in Azure, or create a cluster in AWS. And that on itself, it's pretty big. It does a couple of other things, like allows us like compositions that I will be talking about a little bit later on, but it does also support multiple cloud providers. And it's such a generic model that you can extend with any other SaaS service, not only creating clusters. So as I was saying, with Crossplay, you start seeing a little bit more, it becomes a little bit easier to think about like multi-cloud setups when you basically have a declarative way to define what needs to be created in different cloud providers. You install Crossplay in a cluster, basically in a Kubernetes cluster, and then you send a YAML file saying, hey, I want a cluster. If you have like Google Cloud credentials or AWS credentials or Azure credentials, it will go interact with that provider and create the resource that you're asking for. And it's not only creating clusters, it can create whatever resource that cloud provider is offering you, right? Like you can send like, create me a database, and it will go to Google Cloud SQL and create a database for you. The model is really nice because it works like Kubernetes, right? Like it's not just creating, but it's reconciling all the time. So when you send, for example, create a cluster, it will create a cluster if it doesn't exist, but then it will also keep monitoring the cluster in the cloud provider to see if the cluster configuration changed for the configuration that you sent. So it will also take care of configuration drifts, right? Like, so if somebody is going directly to Google Cloud, like the dashboard there, and changing the configurations of that cluster, Crossplay will recognize that and it will try to reconcile, just try to push the old configurations or let you know if there is a configuration drift in there, which is pretty nice as well. It's a really nice solution, and I think that's why it's becoming so popular, because it's allowing you, first of all, create resources in different cloud providers, and then it has that reconciliation loop that some other tools in the infrastructure as code like space doesn't have. Like if you look at Terraform or Pulumi, basically these tools allows you to say, okay, create a cluster. They will just go and create a cluster in the platform, but then nobody is going to monitor that cluster that was created. They have some integrations, but Crossplay is very Kubernetes native. It actually works like Kubernetes. And it opens the door for that. Like when you send a deployment to a Kubernetes cluster, that deployment will run inside that cluster. In this case, we will send a resource to a Kubernetes cluster that will have like a representation outside of the cluster. It's like an external service. So you can actually go and extend Crossplay to deal with other services that are not cloud provider services. It might be something internal to your company as well. And it does allow you to compose things. And I think that this is another key thing from Crossplay, that usually gets overseen, but it's really important. So basically what it allows you to do is to say, these 4 things are called my thing, and I can define it with a YAML file. And I can not only create things, but I can configure things to work together, right? When you create like a Kubernetes cluster doesn't come alone, right? Like you can create a cluster, but if nobody can access the cluster, then nobody will be able to use it, right? So for example, this is like a much more complicated example, but if you create a cluster in GKE, you also need to create a network configuration so people can access it. So you're not just creating a single resource, which basically means that you need to have a way to compose multiple resources together and configure them so they can talk to each other, right? Like, and they can serve like a higher level purpose. They allow you to do this, and basically what you do is you create like a new custom resource definition that will represent that composition and those configurations. So when you send that new type resource that it's kind of like very custom to you and that combination, that will basically generate the creation of all these resources and the configuration of all of them together. If some of these resources just goes down or gets deleted, the entire thing will change its state, and then Crossplay will just try to keep configuring that until the things are ready and ready to be used by your users, basically. So Crossplay is a great project. Don't take me wrong, like I think that it's definitely heading in the right direction. But as mentioned before, right, like creating cloud resources will cost you a lot of money. Creating clusters in Google Cloud, it's really expensive. And when you work for large companies, maybe that doesn't matter, but when you have 100 teams creating all clusters, it just goes out of control pretty fast. And creating clusters, Dan, you didn't mention that specifically, but when you create like a Kubernetes cluster, basically in a cloud provider, you are creating kind of like the control plane, that it's basically the software that runs Kubernetes itself, and that's not adding any value to your company, right? So usually you're just paying for running machines, for running software that it's not actually adding any value, and that's usually, like you can be a little bit more efficient there. Another thing is that you need to manage Crossplay on itself, right? Like if you install Crossplay in a Kubernetes cluster, that is a complex piece of software that it's managing credentials for different cloud providers and have access to different accounts. So you need to get like some experts on Crossplay in order to be able to manage this at scale. I've been talking with the Crossplay folks, and they have these use cases where they have companies that have multiple clusters with multiple Crossplay installations, and they need to manage that. Again, just very, very complicated stuff. You need to reach to a certain level of maturity in order to do that, and that basically takes time and resources. And yeah, and that's basically come with that cost of, usually what you will want to do is you want to have like a separated Kubernetes cluster to run Crossplay itself, because you don't want to run Crossplay alongside your applications. And that's where vCluster comes into play, right? Like again, Dan did a great introduction. The idea with vCluster is that you can create clusters inside clusters, which it took some time for me for the idea to sink in, because you're actually not creating clusters inside clusters, you are just creating an installation of an API server in it. So you're using the host cluster, in this case the main Kubernetes cluster, to schedule all the workloads, right? Like there is nothing scheduling things inside the virtual cluster itself. So if you think about the things that we are creating when we create one vCluster, is just one API server, one database to store the resources, and then there is another component that is called Syncer that basically takes whatever you send to that API server and send it up to the Kubernetes cluster that's going to actually schedule to run the containers that you want to run. Right? And it do this like bi-directional thing to basically let you know what's running on the host cluster, but in a way that it looks that it's running on the internal API server. It's pretty nice, pretty simple, and it does give you that isolation between API servers, so you can just actually share this across different teams. Something that it took me even more time to understand is that usually I would think that using vCluster will require me to install something in the Kubernetes cluster, and it's not the case. You just install a Helm chart. So again, because it's just an API server, it's just installing a Helm chart into a namespace that will just run some containers to do that virtualization, and that's pretty much it. Pretty cool, pretty easy, pretty nice. You have seen this table before. I will not go through this because it's pretty clear, big selling point that it's there in the middle. I've seen a lot of companies starting with the namespace approach and then just very like scratching their heads to say, well, okay, when I need to create new clusters, for which customers or for which teams should I create new clusters? So let's go to the example. We are building a platform. We have like these folks needing like new development environments. They will send a request to the platform API. They will get the platform will go and create something, and they will get the credentials to access that environment, right? And I think that I want to make a special focus here on environment. I'm not talking about clusters here. I'm just talking about environment. So it's a bunch of things that needs to be created, not just a cluster. It can be a cluster, but also it can be a vCluster, or it can be a namespace. And not any kind of environments. You can create different kind of environments, right? Like for example, you can create like a staging environment, like a larger environment in a cloud provider, right? And the cycle, the interaction should be the same. You send a request, you get the credentials, you connect. You actually don't even need to know where that thing is running. If you are using Crossplay to do that, then you can plug in your cloud provider there and it should work. And if we are like thinking about more like development environments, that's where kind of like vCluster come really handy, because you can reuse the same large Kubernetes cluster to just provide like different teams access to isolated environments. I wrote like a blog post about this, which basically discuss about all the things that I need to configure in order to get this working. But I will share kind of like, I think that I can share another link at the end with like the step-by-step tutorial on how to run this demo. So our platform can create clusters, and this is really good. Like it took me quite a while to arrive to that point, because using Crossplay and vCluster, I haven't found anyone like actually doing it like that, like publicly. So the example in that blog post got really, really popular at some point. So we can create clusters using a declarative approach, right? Like again, I haven't shown it yet, but with Crossplay, you send a YAML file in the same way that you send deployments, and now you are creating clusters or vClusters in this case. We can compose cloud resources using Crossplay, again, using this idea of having a new resource type, creating a composition of cloud resources. For us, it's great because it gives us kind of like an API that we can use to abstract away all the complexity on where these things are being created. And vCluster gives us that like advantage. We are not creating full-blown Kubernetes clusters for each of our teams. We are just creating vClusters. It's way much more expensive. It is a big change, definitely big change. But the problem here is that this is just the beginning. Like if you can give Kubernetes clusters to developers, they need to basically then decide what tools are they going to install, how they are going to work, which kind of like GitOps workflows they are going to use, which GitOps tools they are going to use, how are going to containerize application and all that stuff. So we definitely need to talk about tools. And that's why I'm using Knative here as an example. Knative is one of these tools that you install in your Kubernetes clusters, right? And as Dan was mentioning, these tools are like cluster-wide. Like these tools are cluster-wide. So you just install it once for the entire cluster to use, and you can then use Knative into different namespaces. Knative is usually very associated to like serverless. And the reason for that is that it provides a scale down to 0, right? Like, so when you deploy in Kubernetes, you usually need to have always one running pod for your applications. With Knative, because it has like a custom autoscaler based on traffic, it can actually remove the pod if no one is sending traffic to it. It also does a bunch of other things like advanced traffic management, which is very useful when you want to implement different release strategies like canaries or A/B testing and this kind of stuff. And it does focus a lot on the developer experience side of things. The idea here is that Knative introduces a bunch of abstractions with some opinionated names like service, which already has like Kubernetes, but this is just a much more simplified thing with a lot of other features around it. But again, you need to install it, you need to maintain it in every cluster, right? So if you start having kind of like multiple clusters, in this case, imagine that we have a platform that is creating clusters. You need to install Knative in all of those clusters. Again, you are installing components that are not being reused, and you will need to pay for running these components in every cluster that you are running. And I think that's kind of like the focus of this presentation, to talk about this, which is vCluster plugins, which is something kind of new, I would say. I went to Valencia and I discussed this with Ishan, a friend that is working on vCluster. because for like we were building a demo, and for the demo it was pretty clear that we needed something like this. So if you are using vCluster, you can add plugins to the clusters, which basically will enable the vCluster to virtualize other resources that are in the host cluster. So in this case, I can install Knative on the host cluster, but I can enable all the vClusters to use Knative services. And now the virtualization and the syncing will happen between this kind of like the host cluster and the virtual cluster, which basically means that now I have created, like, for example, 3 development environments. They are all sharing the same, installation of Knative, and I'm running Knative once. I'm not running Knative 3 times or n times if I'm creating n environments, right? So that's pretty cool, and I think that this sharing of components across different clusters, not only vClusters, is something that's going to come into the Kubernetes community pretty strong, because again, if you think about all the tools that we need to install in the clusters, and if we are creating multiple clusters, then it starts making sense to start sharing some of these things across multiple clusters and doing syncings. So that was kind of like the introduction, just to show you a very simple demo that I have built using all these things in action. So let me try to show you that, and apologize for the names and things. It's because this demo I will just reuse it in another conference. So most of the names are just making weird references to other things. So first thing first, let me see where I am. I am in the wrong directory there. Here. Okay, so first of all, I have created that new resource. It's called environment. Can you all see that? Yeah? So it's called environment. New type, new resource type in Kubernetes. This is an extension, of course. So we are extending Kubernetes with a new resource type. It has a name, in this case, DevEnd KubeCon, like conference. And I'm setting here basically the kind of environment that I want. I want the development environment, right? And then I can set a bunch of parameters, for example, the team name or the database size in gigabytes if I want an environment with a database, right? So basically I can have like this very, let's say, simple interface where I can configure the type of environment and then a couple of parameters, and then the platform should know what to create based on this, right? So if I apply this to my platform, I'm hoping to be connected to the right cluster. Let's try. The idea here is I will just, send a request to my Kubernetes cluster that in this case is hosting my platform, right? So I'm sending that request. Finger crossed. Yes. So basically, I've just created a new environment. Now I have a new development environment without the need of defining where that environment is, where it needs to be created, how big it is it a cluster or is it not? Spoiler alert, I'm using vCluster for development environments. That basically means that I've just created a vCluster right down there, right? And because it is a Kubernetes resource, I can do kubectl get envs, for example. Get env, yes. And I will just have a list of all the environments that I've created, right? If I go and send another request to the platform, I will have multiple entries there, right? Like I will just have one resource per thing. So what happened? So when I send this request to the platform, Crossplay is installed in the platform, and it's using something that is called Helm Provider to install the Helm chart of vCluster, and it actually created a vCluster, and we can use the vCluster CLI to list that, right? So there is a new vCluster that was created with the name of the resource in this case, and the thing that I can do later next is to connect to that. So if I run that command, vCluster connect to the name of the environment, and that's where the API server is, I will be connecting to this new environment. And this is basically the same of going to Google Cloud and getting the credentials to connect to the cluster, or going to Amazon and getting the credentials and connecting to the cluster, right? So vCluster in this case, the CLI is just getting the credentials that are stored in a specific secret inside the cluster and then just allowing me to connect to that. So if I do kubectl get namespaces, for example, now, I'm now inside this new development environment cluster, right? And I'm expecting the developer experience for connecting to this cluster, which is a vCluster or a Google Cloud, like a GKE cluster in Google Cloud, would be the same. I will just be using kubectl. And that's pretty cool because, because I can just connect to clusters and abstract away the creation of the cluster from the user. And I'm just doing that because I'm using Crossplay, the resource model, compositions to create clusters and configure those clusters with certain tools. But I'm also using the Knative plugin. So basically, if I exit here, so if I exit the connection there, and I get the namespaces, so now I'm in the platform cluster, which basically has Crossplay installed, it has Knative in there, and it has a namespace for the vCluster that I've just created, right? When I created the vCluster, it's using this Knative plugin, which basically means that if I connect again to the cluster, I can start deploying Knative services in it, and it should work. In order to do that, what I will do is I will create a new function, which is something that we can do with Knative now. Like, we have a specific project that's called Knative Functions that will basically allow you to create, build, and deploy a function without writing Docker files or writing YAML files to deploy that to Kubernetes. So I am connected to the new development environment here. I will go to a new directory. I will create a new directory, Loft Meetup. Right, and I will use this CLI that it's called func. And I will just create a new function based on a template, right? Like, the idea here is that if you are building a platform, you should be able to have a collection of templates that will use libraries that are blessed by your company, or connect to databases using certain drivers and all these things. So as soon as I created the function, the next thing that I can do is I can just actually deploy the function, right? Like, I created like an empty template that will do something very silly. And then the next thing is just running this command. I will just be, damn it, okay, that's a problem. But it will take some time. So we are using something that it's called Buildbox. I don't know if anybody heard about that project. It's a CNCF project that basically the idea of the project is that you send it code to a build pack, and it will detect what kind of code in which language it is, and it will allow you to create a container image for that source code, which is pretty cool because you again separate the responsibility for the developer. You don't put the developer in a position to say, this is the Docker, like the base image for my Docker containers, which is a huge security and big headache. With build packs, basically you delegate that to the platform that will decide, okay, which build packs are available. So you send me the code, I will detect what language and which frameworks are you using, and then I will build a container for you. What it's downloading now, it's basically it's kind of like the core of the project that gets released every day. And the main reason why it's released every day is because if you use this base layer, you know that every day like security fixes are applied, right? Like, so every time that you build, in this case, the function, if there is a new security vulnerability, it will be automatically patched on the base layers. So it's pretty cool, but it takes some time. If you usually, like, what you do is you cache these and then you define like your company policies on when to fetch these. But it's done now. So now the next step is basically going to build the source code that it's like in Go. In this case, it's just a Go, very, very simple Go function. And it's going to build that. You can see that it's installing Go inside the container and then just building the project. And as the result of this command is we're just going to get a URL to basically interact with that function that it's running inside the development environment that we created, using basically Knative in this case. This is also, of course, pushing the image to Docker Hub in this case, and that will make it available in my vCluster inside my Google Cloud cluster that is running in GCP. So as you can see here, I have a very long URL, but this basically represents where the function is running. As you can see, it starts with Loft Meetup, which is the name of the function, then in the default namespace, but inside the VM KubeCon virtual cluster that I'm running, right? And then the last part of it is the host cluster IP address that I need in order to route the request to this cluster. So if I go to my browser here, we can actually run and just get some rainbows here in London, beautiful rainbows. So again, the idea here was that I started with nothing. I requested an environment by sending a YAML file to my platform. I got the environment, connected to it, and I'm sharing a single Knative installation across all these environments, which is pretty cool. It provides me kind of like automatic routing of the traffic into the cluster, and I can start doing kind of like crazy release strategies here, like for example, having multiple versions of this function running at the same time and sending requests to the different versions and all that stuff. I think that I will leave it there because I think that it's getting late. But this is what we have done. We created an environment, we sent the function, and we deployed it. And I have like another part of the demo, which basically, where I basically talk about that, right? Like, this is great, like using tools like this, like Funk, to deploy things into development environments. But when you're going to do like more production workloads, you will probably use like something like Argo CD or Flux CD to do more like GitOps approach, right? So the next step is just basically not to show that I will do a deploy to my production environment, which is a different cluster, but that basically I will just merge a pull request in a Git repository so that gets synced. And it takes me all the way from developing something in a development environment to having something running in a separate cluster that was configured, for example, with HTTPS and Cert Manager and a bunch of other things. So, but I will leave it like that. Again, just go and buy that. Yes, you know how it is. But yeah, thank you very much. And I know I went pretty deep on some of these things, but and pretty fast because I hadn't had much time.